Hello and welcome. My name is Dervis. I work for the Norwegian government, and today I'm going to talk about consumer-driven contracts. It's a testing pattern, and I'm going to tell you why we have chosen to do this thing in Norway. First of all, who am I? I'm not talking on conferences that much, so bear with me. I'm usually behind the camera. I'm part of the Norwegian Java community. I organize meetups, and I help out with the Java Zone conference in Norway. I am also co-organizer of the software Architectural Group in Norway, which is one of the largest in the country. And I have 10 years of experience, and I just recently joined the Norwegian Welfare and Administration. I will come back, because working for the government as an employee is a bit unusual. So this presentation, it's about why did we need to use consumer-driven contracts? And I will tell you what it is. I will show you how it works. And unlike the existing talks you can find on YouTube and on the net otherwise about this topic, I will show you deployment pipelines, because this is something that we worked a lot to understand and to learn. And code examples, of course. Okay. So, Norwegian Labor and Welfare Administration. This is the government administration in Norway that is responsible for most parts of the Norwegian society. It provides health care, disability support, work, children, pension. It serves 2.8 million people daily, and there is a very huge numbers in terms of money involved that is circulating every single day. And it's architecturally, it's also one of the most complex systems in Norway also. Okay. The IT systems of the Norwegian Labor and Welfare Administration, it has been along for a lot of years now, and this is how it was looking until recently, and some of this stuff is still in use. We have multiple different platforms for our services, ESB, BPM, data power. This is all IBM products. Many SOAP services. Too many test environments. And the organization itself, the welfare administration, it's organized according to ITIL and PBR, Plan, Build, Run, which is basically, it affects the way we run projects, the way we run the organization. And before, we had this thing called centralized integration team. And these guys, they was responsible for writing web services, providing the artifacts, distributing them, versioning the services, etc. And beside that, we have some very old COBOL and mainframe systems. And these old mainframe systems, they are actually the very core of the Norwegian society. and they're still running, except that in 5 years they will be replaced by Java and Kotlin. Okay, too far. Okay, so what happens to an organization when you have ITIL, PBR, web services, too-many test environments, complicated architectural landscape? Well, it evolves into something like this. This is called monolithen. It's the only monolith that I know about. When your organization gets too many of these, too many monoliths, you basically get into a lot of other issues. So among the challenges that the Norwegian Welfare Administration had now for the last 10, 12 years is something like this. Change requests. My team, if I need a change in the web service, some corporate service providing me information about citizens, for example, I will send them a change request from Jira. I will tell them, hey, there is a bug in this service, I need a change. Well, and it takes, let's say, 6 months, or 3 months. So with waterfall projects and this way of organizing the organization, well, it leads to things such as this one, like blame games. No, it was your fault, not my fault. No, it was your fault. So the communication breaks down, basically. And the second thing is that the web services and too many test environments and all these things leads to integration test hell that you might have heard of. And the most difficult thing, maybe, it's also branching chaos. Some projects that are not doing continuous integration and continuous delivery, they have this very complicated branching. Release 2018 Q4, for example. Having too many of those is also it will lead to very disastrous results in the long term. And this image which you see on the bottom is the one way of doing projects, where each process is basically separated, and you have this handover between each phase. Running an organization, especially a government administration, like that, it's extremely costly. And over the years, maybe the last 2 years, a lot of Norwegian developers, they realize that, hey, we have to care for the systems. So a lot of developers, they basically start working for the government to help carry the organization further. So what we did now, we did many changes. I'm going to talk about one of them, which is Pact. And there is definitely much more stuff that you can take a look at, and I'm going to mention some of the important things like Swagger and Open API specification. Okay. So what is consumer-driven contracts? This is not entirely something new, because it's been around for since 2006. And very simply said, it's your users telling you what they need and how they need it. And they capture their expectations from you in a separate file, and then they share it with you. And this contract which is produced is tested on both sides. both on the provider side and on the consumer side. So the consumers use it to mock their services, while the providers are using to validate their APIs. The good thing about this thing, which I hope I will show to you in the code in a little bit, is that breaking changes will be visible before you deploy. So you will see what is breaking before you're going into production. And there is 2 ways of doing this with Pact. One is consumers asking, can I deploy? Providers by running provider tests. And consumer-driven contracts is another tool to help you develop better software. It's not meant to replace existing ways of doing testing. Integration tests have its benefits and disadvantages, but the same thing for end-to-end tests, and it's increasingly difficult to implement them and increasingly complex and time-consuming as well. But it's not meant to replace them, so you will still need to have them, but we will see. Consumer-driven contracts with Pact is simply unit tests. It's integration test actually, but it's mocked integration tests. So when you're running your Pact integration test, you're not calling an externally deployed service. You are stubbing the service that you are going to talk to, the API that you're going to talk to, you stub it locally, so you don't need to make an external call. And you can do that with different well-known technologies. And it's meant to test HTTP APIs. So unlike the talk that was before me with Jonathan, this is for HTTP and JSON-based APIs. This is how it looks. So you have the consumer and some provider. You have the API, JSON, and then you have something called Pact Broker. The Pact Broker, which I'm going to show you, it's the place that you share your pacts, where the providers can automatically download them and verify their own APIs. And the way it works is something like this. So you have a consumer application and some backend provider. The consumer runs its integration test, and what the Pact framework is doing for you is automatically uploading the Pact file. And then on the other side, completely in isolation, the provider running its provider test can download this Pact file and use it to verify. So this is happening in complete isolation. So both the consumer and the provider can write their tests without actually having any kind of dependency on each other or any externally deployed services. Okay. So my first example that I'm going to show you, is an example using Maven and Java and Spark and JUnit 4. And do you know Spark? Anybody tried Spark? One? Yeah? Spark is a very lightweight framework for writing web HTTP APIs. It's a web server, and it's a very simple thing. It has embedded Jetty. So let's look at how it looks. So my demo, which I'm going to show to you, is an example that I basically implemented from Martin Fowler, which was one of the authors behind this concept. And it's the API is that you can ask for information about people. So you have the one server showing you persons, and then you have different consumers. Those consumers, they have their different requirements. One consumer may be using just one field, and another one which is using all of them, maybe. So that said, yeah, okay. So this is a JUnit 4 test. It's no, sorry, it's JUnit 5. This is it. There is nothing more than this, actually. In here, you have the DSL. And the DSL is basically your way of writing the interaction that you expect from the provider. So you are saying that given that a call is happening to this URL, with the method get, I expect the API to reply me status 200 with the headers, which I have written here. And I also expect that, if you see this part, given an ID, I'm going to return a JSON body with the information about the user that you requested. And then you generate the packed file. And this part here, this is called a fragment. You can have multiple fragments that eventually will be merged to one packet. This is where you are actually testing, and this is maybe the important thing. You are testing your own interface. So I have my person service is very simple thing. It makes HTTP call, which is here with the Apache. So what you want to do here is actually finding bugs in your own interface. The stuff you don't care about is this stuff, the mock, the stubbed server, because you pretend that you're making calls to the real service. And then you make assertions. In my service, I'm converting with JSON, with Jackson. I'm converting the response into my own domain object. And when you're writing the contract first, and then you are testing your own interface. Starting out like this, you'll soon see that you can actually find a lot of bugs in your own consumers. And it's also a way to ensure that your consumers will keep working also. So this is the consumer. And here is the server. This is the provider. This is Spark. I define the port. I tell it that here is the path that my API is available at. I map some exception, and this is my API that simply just returns a user, which is if it has that. This is a very extremely simple example, but I hope it illustrates the point here. And together with this, I have a provider test. The provider test is going to make a call to the Pact broker and download the Pact file, and then automatically verify. It will replay the interactions, which is defined in the Pact file. And this is in complete isolation. So no communication between the provider and the consumers. And this allows you to test your provider in your Jenkins servers or other places in complete isolation. So let's see. When I'm running my build now, you will see that it starts there. If you look at the output, it's running the test, and in the middle here, you see that it starts the mock stub, the server, and it's basically does the calls, and it captures the calls that you make in your consumer, and then verifies that the interactions was accordingly. I'm running my provider tests now. It starts an embedded Jetty process, runs all the tests, replays the Pact, the interactions that our consumers expected. And this stuff is coming from the Pact that was published to the Pact broker. I will continue now, and then I will show another example where we actually make changes. So why are we doing this? And the whole point of this is, if you have a service and you have users that consumes your API, when you make a change in your service, in your, let's say, backend service, you don't want to break every other consumer out there. And on the other side, your consumers, they want to be confident that they can actually deploy their applications to production without being afraid of failing. So if you have an example of a front-end application and a back-end application, numerous times, me and probably you also, we have been in situations where the front-end application makes a call and expects a JSON, and then suddenly some expected field is not returned from the server. So you talk to your back-end people, hey, what happened here? This field was not there, and they reply to you, well, didn't you follow on Slack? We changed. Oh, great. This is the stuff you want to avoid. And the way we can do this thing is by integrating Pact into your build pipeline. So these are the two cases that I was talking about. You want to be able to change and deploy without failing everything else around you. And my code example here today is based on CodeShip CI. I'll show you how that works. And this is the example that I showed it to you. We have a provider, and we have 3 consumers. They each consume different parts of the API or the response. So The interesting part now is they are calling the same endpoint. So given that they called this endpoint, they will get this response, which is identical to them all. But what happens now if a fourth consumer comes in and he says that, you know what, I don't want this name field, I want first name. It needs to be called first name and last name. So they expect something completely different. This is their expectations, which is down here. So how do you deal with that situation now? You have basically two choices. You can make a new version of your API, and you can call it V2. And then our paths become like this, /API/V2. And the other way of doing this is applying the robustness principle. And it's also called Apostles' law. So I will show you. You can read much more about this in Martin Fowler's website. I'm just scratching the surface here. If you go with versioning, API versioning, and you call it V2, there's some stuff gonna happen. The first and maybe the important thing is here that you couple different consumers to specific versions. And that, in turn, increasing complexity in your code. You have duplicated code and potentially more bugs, because if you fix a bug in your, let's say, V2, and you might break something in V1 and vice versa. So this is more versioning. Again, this is just scratching on the surface. Is more used with public APIs. So you can use it, of course, in your internal APIs also, but you have to be aware of this stuff. Okay, so robustness principle. How do we deal with this fourth consumer? The Apostles' law says, be conservative in what you send and be liberal in what you accept. Turning that principle into code, you have be liberal, you apply JSON ignore properties. This is Jackson specific, by the way, because what I have experienced is that Jackson has generally better support around. I have used JSON a little bit, but haven't gotten the same benefit, the same effects as I wanted. Be conservative is simply that you leave nulls outside when you're serializing something. So you're not sending unnecessary information, but you're willing to actually accept more information than you need. So the opposite direction with this stuff. So we are still talking about this fourth consumer because we have 3 other consumers and we don't want to break them. And we also want to support the fourth consumer and its requirements. So this is the one way of doing this. It's called multi-step release. So this is what we had. What you do is you introduce this new field called first name. And you also provide the existing field. So what happens here is that you don't break your existing consumers, but you also provide this new field that your new consumer wants. And then you say to your existing consumers, those 3 first ones, and you communicate that this change happened, and that if the provider team chooses to actually continue with this, they can ask them to do the updates on their code, because consumer during contracts is not consumers telling providers what to do. It's actually is the one way of communicating better and noticing when errors happen. So, when everyone has updated, you can safely remove the old field name, and everyone is using the new one. And if you read about consumer-driven contracts and you read Martin Fowler's articles, this thing is, he's recommending this several places. So okay. If there is any so when you're doing your updates to your APIs, you had 3 consumers and you had a new one. If there is any problems, you want to catch them before it's deployed to production. And this is a picture from the Pact broker. This picture is showing the 3 status colors. That is the ones that you can see. When everything is okay, the contract was updated or it was failed. And you can do this thing with a tool called Pact Broker. I'll come back to this one later, but this is a Ruby command line tool that you can use. Okay. Backwards compatibility. Why is backwards compatibility important? Because there are some important things that can happen with Pact when you're using Pact and you're verifying that everything is okay, the consumer contracts was fine, and the provider test was green and everything is fine. But things can still fail, even if you're using Pact. And I will show it to you how that can happen. So what you want to do is, in order to not break something in production, you need to run several tests with Pact. And I will show that. Because you have 2 scenarios which is happening a lot. You might have multiple services in your organization, and all of them might not be deployed together. So some teams are faster than other ones. And other times you deploy everything together, and this has different scenarios, so which I will show to you. This is how it looks when everything is deployed together. So your consumer and your provider both is tested, built, and deployed at the same time. So and they do their testing against each other, and they are testing master branch. And everything is green, everything is fine. And then we have this one. You have your provider doing a lot of changes, and then you have a consumer, well, that is not deploying at the same time. So you're starting in development, everything is fine. And you deploy it to the test environment, and everything is still fine. And then, when it's deployed to production, there is a difference in version here. Now, because in the test environment, your consumer is updated. In production, is not updated. And when you believe that everything is fine on this stage, once you get here, and it's an older version, and that older version might have some old contract, which you didn't test against. So, and that's why, to deal with this, you have to basically test both things. You are testing that, let me verify against the old contract and against the new contract. So if you think about my example, you have to test against the contract that required name, but you also have to test against the contract that required the new updated field first name. And then you can be sure that once both things are actually fine, then it's safe to deploy to production without exploding there. This is Gradle. Time is running, but I will hope to show you that. With Gradle, you can specify that when you are verifying your my provider, verify it against the contract that is tagged with prod. There's a lot of documentation about this tool. One thing I will recommend you to avoid doing is one thing we did in Norway, and that is because working in a government and in government offices means there is a lot of security and privacy going on. So the systems are extremely safe, extremely difficult to steal information out of. So we couldn't get the Ruby running because this is a Ruby tool. So we looked at the communication between our unit tests and the Pact broker, and we made our own scripts to do the same thing. Can I deploy? This is working. However, if you can use the command line tools, which the Pact authors already is providing you, is much better, and you don't need to fall into some issues that we had. For example, that the Pact broker, our scripts was working, and 3 months later it was not working because the Pact Foundation, the people making Pact, they added some new stuff, application JSON, accept headers, and suddenly stuff are not working. So if you can, use the tools. Okay. So I have another example for you now, and that one is this one is Gradle and Kotlin example. I'm still using Spark because it makes me get much faster testing things. It's a to-do application that is a CRUD application, basically. So this is a slightly more complex example. I'm not going to go into details here because all the code is available on my GitHub. So if you want to check this, you can find it on my GitHub page. But, okay. This is my... Here's my backend. This is the provider. And this is the consumer service that is calling the API. And then in this file, this is the consumer side. In the consumer side, I'm telling the provider how I expect the to-do API to function. And I want to show you the last fragment here. And this last fragment is basically telling the provider how do I, as a consumer, expect the post and create functionality to work. So I'm saying that method post, and I'm going to call the root path here, which is /to-do. And given that I post a JSON which has 3 required fields, which you see in the middle here. I have a date also. It supports dates. When you are testing for dates, I recommend you to test ISO 8601 format. And this is the way you can do this. And then I also say that the API should respond with HTTP status 201. And it should also give me, as the response I expect back is an entity. And that entity should contain the URI and the ID to the newly created item. And if you look at this complete file, I have several fragments here. All of these fragments, once they are built, they will end up in this folder on the consumer side. This file is a collection, it's the Pact specification. And the Pact specification is the reason why Pact has multiple implementations. It has implementations for nearly every language that I know about, and even JavaScript. So you can actually write consumer tests in pure JavaScript with Mocha or Jest, and you can run verification tests from Java or Go, Erlang or Python, Java, Kotlin. So that's why. And this Pact specification there is several versions of this. And here's another gotcha. The JavaScript implementation of the Pact specification is behind the JVM implementation of the specification. So when you are testing this thing, you will notice that some stuff are not supported basically in the JavaScript implementation. Okay, so I have 5 minutes left. I will run through our experiences using Pact. So it's very easy to get started testing these things. And you can easily introduce this to your existing Maven projects. And the thing that is hard is that learning how to use the Pact broker and how to integrate this whole thing into your CI is difficult. Or it's not difficult, but it requires time, and you have to be willing to invest that time. You can write your provider tests with Maven plugin or Gradle plugin using the DSLs. However, we used to do this just with JUnit. And with the Gradle, you have this additional advantage that you can use the Groovy DSL to write changes to the Gradle task, which is there. With Maven, there is one important thing that we used the Pact JVM provider Maven plugin, because there is another one called Pact broker Maven plugin, which I do not recommend you using because it's not maintained and is buggy. The official Maven plugin is the one which is better. And there is another thing with the Maven Surefire plugin. It has compatibility issues with JDK 10. So while I was testing these things, I had cryptical errors that I never figured out. And Gradle, by the way, when I started using this, I overestimated the complexity of Gradle. But once you try, and Pact is a great example for learning Gradle actually, it works great, and you can check the source in my GitHub. But I definitely recommend it. The problem is that your team they also need to learn Gradle, so that is the problem. But it's worth a try. Kotlin is the first time I tried Kotlin for this project, and I'm not regretting it. The biggest problems we had was actually Windows, because some of our infrastructure is based on Windows in the welfare department. And the nice thing is that when you have problems, the Pact authors are extremely helpful, and I got a lot of help of them. And I definitely recommend you talking with them through the channels they have available for you. They are very responsive, and me and my team at the Norwegian Welfare Department, we have given our pull requests, bug reports, and stuff. And I definitely recommend that when you are testing open source, contribute also to the repositories, because you can help bring the development much more further. There is finally, I'm gonna jump to this slide, because consumer-driven contracts is from the consumer side, and you let your consumers define contracts. But there is also this another thing called Open API specification. Have any of you heard about that? Yeah. Open API specification is basically old Swagger, and Swagger has donated their specification for this purpose. And what Swagger is allowing you, what Open API allows you to do, is basically letting you specify a contract on the provider side, so your consumers can test. So it's kind of the opposite way of doing contract-driven testing. Yeah, and that's what I had time for. Thank you so much. If there's any question, I will be here. Good communication is very important, because you have to agree as a team, basically. The provider team cannot agree or decide anything alone. The consumer teams, the front-end teams or whatever, they cannot decide things on their own. So you have to agree on using this paradigm, which is consumer-driven contracts. Once everybody's agreed, you have basically established this platform where you can communicate. And starting out here is actually very simple. You download the Pact broker. You need to install PostgreSQL database server. Once those are up, you basically learn Pact, how to use Pact, and how do you write JUnit tests. And once you start publishing the contracts to the Pact broker server, then you will see the value of communication there. But of course, it's difficult. And making sure that everybody contributes is also difficult. So everybody has to be in it. So, but it's worth a try, in my opinion. Yes? Yeah. The first release of Spring Cloud, I think it was called, didn't support the Pact specification. And it also had another problem, that with Spring you had to package your contract as a jar file. With Pact, that is not the thing. So, but the good thing is that version 2 of the Spring Cloud contract does support the Pact specification. So you can actually, if you have Spring projects, you can definitely take advantage of Pact by using Spring Cloud contracts together with Pact server, the Pact broker. So they have better compatibility now. If you asked me some months ago, I would say no, but now it's better. Any other question? Yeah. Thank you.